You ever look at algebra and feel like you're trying to crack some kind of secret code? Well, what if I told you it's really just a puzzle? Today, I'm going to give you the master key that unlocks a huge part of it, the linear equation.
So let's start with a little riddle. This is exactly the kind of thing algebra was built to solve. Now don't worry, we're not going to solve this one right this second. But stick with me, because by the end of this, you'll have the exact tool you need to crack it yourself. And it all starts with learning the language.
And that language really boils down to two key ideas we have to get straight: expressions and equations. They might look kind of similar, but they are worlds apart.
First up, we have the expression. The best way to think about this is like an incomplete thought, a phrase. Like if I said x plus 2, you'd say, and? What about it? It represents a value, sure, but it doesn't actually make a claim. It's just a fragment.
An equation, though, that's a whole different animal. An equation is a full sentence. It makes a complete statement. It says that the thing on the left, x plus 2, is exactly equal to the thing on the right, 5. That equal sign is the verb, It's the action. It's the most important part of the whole sentence.
So, here's the bottom line. An expression is just a phrase. You can't solve it, you can only simplify it or move it around. But an equation? That's a complete statement. It's a puzzle that actually has an answer. It's something we can solve.
So, how do we solve it? Well, there is one single crucial idea that you need to get, and it's all about thinking of it as a balancing act.
This right here is the whole game. I want you to picture every single equation as a perfectly balanced scale. That equal sign in the middle, that's the pivot point, and it is a guarantee that whatever is on the left side has the exact same weight, the exact same value as whatever is on the right.
But watch what happens if we mess with that. What if we just plop something extra on just one side? Whoop! The whole thing tilts. It's not in balance anymore. The two sides are not equal, and our equation is officially broken.
So how do we fix it? Well, to restore that perfect balance, we have to do the exact same thing to the other side. We added something to the left, so we have to add that same something to the right. This isn't just a helpful tip, folks. This is the unbreakable golden rule of algebra.
Let's just let that sink in for a second. This is the key that unlocks absolutely everything. Whether you add, subtract, multiply, or divide, it doesn't matter. You can do whatever you want as long as you do it to both sides to keep that scale perfectly level.
All right, now that we have our golden rule, let's actually put it to work. Let's use this balancing act to solve for x, our mystery value.
Okay, let's start with a nice easy one. X plus 2 equals 5. The goal here is simple. We want to figure out what x is. And to do that, we need to get it all by itself on one side of the scale. We have to isolate it.
So right now, x isn't alone. It's got that plus 2 hanging out with it. To get rid of a plus 2, we just do the opposite. We take 2 away from the left side. But our golden rule, if we take 2 from the left, we absolutely have to take 2 away from the right to keep things balanced.
And in the language of algebra, that's exactly what this looks like. We're subtracting 2 from the left side, and we're subtracting 2 from the right side. We're just mirroring the action from the scale.
And just like that, look at that, the scale is perfectly balanced again. On the left, the plus 2 and the minus 2 just cancel each other out, leaving x all by itself. And on the right, 5 minus 2 leaves us with 3. The puzzle is solved. X equals 3.
Okay, warm-up is over. Let's try a more complicated puzzle. Now, this one might look a little intimidating, but I promise you, the principle of keeping things balanced is exactly the same.
First things first, it's messy to have x's on both sides. So let's clean that up. We've got 5 on the left and 2 on the right. So let's just take those 2 x disks off the right side, and to keep the scale balanced, we have to take 2 x disks off the left side too.
Here's what that move looks like in math terms. We subtract 2x from both sides. This simplifies our equation down to a new, but still perfectly balanced state. 3x plus 4 equals -8.
Okay, now this looks familiar. We need to isolate that 3x term. To do that, we have to get rid of that plus 4 on the left, so we take 4 away. And to maintain balance, we also have to take 4 away from the right side.
So, algebraically, we subtract 4 from both sides. The plus 4 and minus 4 on the left just vanish. And on the right, -8 minus another 4 gets us to -12. Oh, we are so close.
Now, we don't want to know what 3 x's are equal to. We want to know what a single x is. So we perform one last balancing act. We divide the contents of each pan by 3.
And there it is, our final answer. The scale is perfectly balanced, with 1 x on the left and a value of -4 on the right. By applying that one golden rule, step by step, we navigated the whole thing and found the solution.
But just when you think you've got it all figured out, there's one last little wrinkle. Sometimes, when you try to solve an equation, something kind of surprising happens.
It turns out equations pretty much come in 3 flavors. Most are conditional, meaning they're true for just one specific answer, like we just found. But sometimes you find an identity where it's true for any number you plug in. It's always balanced. And then there's the contradiction, an equation that can never be true. It's a scale that's just impossible to balance.
So an equation is way more than just numbers and letters. It's a powerful tool for finding a single point of balance, a single truth inside a complex system. It's the logic behind engineering, finance, science, you name it. So my question for you is this: what puzzles in your world, what problems of balance, could you solve with this kind of thinking?